Hello once again and welcome to lesson number 6. Okay, without any waste of time, I want us to start with our presentation for this particular lesson. Okay, so this is our presentation for lesson number 6. Okay, I want to take a highlighter. Then we can go and start this presentation. Okay. The lesson goes like this and is a programming exercise which will be executed on main OB1. Okay. When the start button is activated, motor A and motor B starts rotating immediately. Okay. So when the start button is activated, motor A and motor B will start rotating. Okay. 10 seconds after both motors have started, motor A stops automatically. That will happen after 10 seconds. Motor A will stop after 10 seconds. Okay. 10 seconds after motor A has stopped, motor B stops automatically. So this was happening. When the start button is activated, motor A and motor B will start rotating. A delay of 10 seconds after both motors have started rotating, then this motor, which is motor A, will stop rotating automatically. That will happen after 10 seconds. A further 10 seconds after motor A has stopped, motor B will also stop automatically. Okay. So we have a situation here where when you press that button, motor A and motor B start rotating. 10 seconds later, after both motors have started rotating, motor A stops automatically. A further 10 seconds after motor A has stopped, motor B stops also automatically after a further 10 seconds. Okay. If the emergency stop push button is activated, both motors will stop rotating at any given moment. Okay. So this is the situation. So I want us to go and open the software and start programming in OB1. Okay. I don't want to keep that. I can actually minimize that. Sorry about that. Okay. So we're going to have to open the software. Then I want us to start creating the new project for this particular lesson, which will be lesson number 6. Okay, so let us create the new project and then let's call it, say, lesson number 6, something like that. Okay, create that particular project. Okay, you can see it's creating the project for us. There you go. Now, I don't want to waste time because I want to minimize. I think my videos are too long. So let's add a device on our project, add a new device. And then we go to controllers. We go to an S7 Symantec S700. We add a CPU there. We select the CPU that we want to use. Let us choose a CPU 315 2DP in this case because I want us to now start using Profibus communication. Okay. already selected that particular CPU. Okay. You can see it is loading the CPU onto our hardware configuration. It's taking some time, but it's gonna load. There you go. Now, this is your hardware catalog. This is your hardware catalog, as the name says, hardware catalog. Okay. So I need extra parts of the hardware. I need to add some hardware here. I want to add a power supply there. Okay. And I also want to add another digital input card. Okay. Signal module. Okay. I want to add a signal module there. And I want to add a 16-bit digital input signal module. Okay. That's what I want to do. So I go to DI, then I add a 16-bit digital input card. Then I also want to add one 16-bit digital output card. Then I go to DO in this case because I'm looking for digital output card. Then I also want to add a 16-bit digital output card there. Then there you go. This is my hardware based on the project. I save this. I close my device configuration. When I'm here now, I want us to learn a new thing now where if you want, you can actually edit your text on an Excel file, or you can export, like what we did on lesson 5. We exported the text onto an Excel file, then it was saved on the desktop. So I want us now to import that file onto this particular project for usage. So how do you do that? You can go to text and open the default text table. Then you can actually right click here and go to import file. Then you go to desktop, you select the Excel file, you go and select the file, then you enter. You open that file, so it tells you import completed successful. So the file has been imported. As you can see, there is the file, the motor sequence file. There it is with the text. Okay, I've already edited those texts. Start push button, the stop MB, there's the motor A, motor B, and the stop. Okay, then we save that and close, and also close that. Okay, now we've got the text for this project. Now I want us to start programming. We go to program blocks like we did before. We open main OB1, then we start writing those instructions. Okay, so I want us to go to network 1. On network 1, we can type in start motor 1, or you can just type in, I say motor, let's go motor 1, or start motor 1. Okay, start motor, or start motors, something like that. Okay, no problem. Okay, so what we want to do here, we want to add, say, an e-stop, a start button, and we also want to add a coil for motor 1, like we did before. Okay, so this is my e-stop, This is my start button, normal start button. We use this one in this case. is I 0.1, and then this is motor A. Okay. What the instruction says, if you press that button, motor A will start rotating and also motor B will start rotating. Okay. Now, I want to also, let me change that comment to say start motor A so it can make sense. Motor A. Okay, then it's going to make sense to us. Okay, I know I need to retain that. I need to create that branch. Okay, undo. Then I'm going to do this. Okay. Then I want this to be MA also. So it can retain itself. Okay. Then at the same time, I'm going to write the same network but with different addresses for motor 2, okay, or motor B. This one will go like start motor say B. All right, there you go. This goes like this. It is exactly the same but with different, these will be different. Okay, but let's just wire it up, it's not a problem. So we add the e-stop, we add the start button, we add the coil. We build the second exactly as that one, not a problem. There you go. Okay, but we change those addresses. This will still be an e-stop. That is your start button. That one is your motor B. This one is also motor B, as you can see. Okay. The start button is exactly the same. These two is one button. Even these two is the same thing. Okay. Now, I want us to look at that instruction. We go back to our PowerPoint presentation where we were saying we press that button. Press that button is activated. Motor A and motor B starts rotating immediately. 10 seconds after both motors have started. 10 seconds after both motors have started, motor A stops automatically. Let's do that part first. We go back to our software, which tells us that on network 3, we need a delay on timer. So we put in a delay on timer there. You can just type in. You can just type in delay on timer, something like that. So we can type in for motor, say B. They don't must be caps. Motor A in this case. Okay. All right. So we delay on oil timer for motor A. We insert that. So we want, when this motor is energized, to also start a timer immediately. So we insert a delay on timer there. Then it gives us an instance data block for this function block. Okay. All right. So I want us to rename this to give it a name timer 1. Okay. There you go. And then it's gonna wait for 10 seconds. Don't forget that. This thing is giving me, I'm gonna wait for 10 seconds, 10 s. Okay, there you go. Happiness. Okay. Now, this is being controlled by a normally open contact from motor A. Okay, happy? Then the output of this timer needs to stop this coil, this motor A, from running after 10 seconds. So I'm gonna wire up or add a normally closed contact there that belongs to this timer here, such that excuse me, so that after 10 seconds this output here will open this contact such that this motor will stop rotating. So I'm going to change that address and put timer 1 instance data block Q, which is the output. Okay. Excuse me, sorry about that. Okay, I think I'm catching some flu. Okay. So as we can see that this output is being stored on db1.dbx 6.0. Okay. Which tells us the location where the status of this normally closed contact is, where is stored, is being stored in this system block. Okay, here it's being stored here. Let us open the data block. Okay, this is what I'm talking about, where is here. Okay, it's the Q output, that's where it is. Okay, db1.dbx 6.0, as you can see there. Okay, db1.dbx 6.0. Hope you guys can see that. Okay, so such that when the start button is pressed, this timer, this will start rotating, hence it will activate that, then the timer will start counting. After 10 seconds, it's going to open here, then the motor will start rotating. Okay, are you happy? Now, we also want to look at the next instruction where we said 10 seconds after motor A has stopped, 10 seconds after motor A has stopped, motor B stops automatically. We also want to do that and program that. Okay, so we go back to our software. This tells us that we must add a delay of timer. Okay, delay of timer for motor B. Okay. Then the question will be, why do we add a delay of timer? You can have one delay on timer and put it at 20 seconds. But since I want us to use a delay of timer so that we can also understand how it works, that's why I'm adding a delay of timer. Okay. So a delay on timer works like this. A delay on timer, this delay on timer here It only works like this when it is still energized, when the coil of this timer relay is still on. The timer would keep on timing up until this preset time has elapsed. Then this contact will change. It will only change when this time has elapsed. Then the contact will change. And it only times when the coil of the relay is still energized. It's a delay on timer. Okay, I'm going to explain a delay off timer once I've added it. Now let's add the delay off timer onto our network 4. So we go again to timer operations. We drag and drop a delay off timer and put it there. Okay, it also pops up a single instance data block, which I'm going to change to timer 2. I press OK. Then I rename this block to timer 2. Okay, let's put T2 there. Okay. Now I'm also going to add 10 seconds there. We go T hash 10 seconds. Happiness. Okay. Now, this is for timer. This is for, remember, this is for motor B. But I want to add now a contact from this timer that is going to make sure that this motor will stop a further 10 seconds. Okay. How do I do that? Now I need to understand how this timer works first. This timer works like this, a delay off timer. Okay. As soon as you energize a relay for this particular timer, the contacts will change immediately. Let me repeat that. A delay off timer works like this. As soon as you energize the coil of this relay, a delay off timer, the contacts will change immediately. So they will change their states. If it was a normal open contact, it will go immediately to normally closed contact. If it was a normally closed contact, it will change immediately to normal open contact. Okay, then it will hold like that. So now as soon as you remove power from this relay, it will now start counting to go back to the initial state. That's how it works. Okay, which takes us to this. We can actually connect a normally open contact there, okay, from this delay off timer. Can connect it in series to this branch here, okay, and then we give it an address. We want it to come from a delay off timer, which is timer 2, and then we want it. No, sorry about that. I was rushing too much here. Sorry. It must come from an instance data block, and it is an output. Okay, there you go. That's where it comes from. It comes from dp2.dpx 6.0, which is the location exactly where it is sitting on the table in dp2. That's where it is stored. Okay, as you can see there. As you can see there. Okay, the offset. All right, now let's go back and see there. That delay off timer, we've just pulled up a normally open contact, and we connected it in there, because we know that as soon as the relay gets power, or this function block is energized, because there's energy there, the current up and in here, as soon as it's energized, this will close immediately, making sure that this motor and that motor start rotating at the same time, because a delay of timer, the delay of timer, as soon as it gets energy, it change its states immediately. So it will change to normally close immediately. Okay, so you're not worried. Now we need to remove power. How do we remove power from this delay of timer? Okay, so it needs to be controlled by something here, such that we can connect a normally open contact there, because of this condition here that goes like this. This condition here says 10 seconds after motor A has stopped, motor B also stops automatically. So it depends on motor A. Depends on motor A. Okay, let's minimize that and go back there. So we can change, we can add an address there, put motor A, such that when you press that button, both motors A and B will start rotating, and then this timer also will start rotating. Sorry, this timer will also be energized. When this timer is energized, it will change its state immediately. This will close immediately, then these two motors will start rotating at the same time. Now, when this timer here, delay of timer here, delay on timer, when this time 10 seconds has elapsed, this contact is going to open, making sure this motor goes off while this motor is still running. Are you following? Then this will now lose energy because of this contact, will lose current. Then it will start timing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then this contact will go back to its initial state. Then it will open, making sure that the even motor B will stop after a further 10 seconds. Okay, I hope it makes sense. All right. Now let us simulate. I'm gonna just I want to actually leave it like this so that we can see motor A and motor B. Then we'll see this contact and that contact. Okay, 100%. Now let us save and compile our project. Then I want us to start simulation. Go like that. There you go. Then we can actually change the TCP. Okay, there you go. You can change this to Profibus because I want this to go to be Profibus. Then we can go to type of PGPC interface. Yes, here we change the PGPC interface. We change that to Profibus. Then the PG interface is your PLC SIM, as you can see there. So there we want to set up a communication between this PC and this controller here, which is an S700 PLC, through a Profibus network. Okay, we start search. So it's looking for something which is connected on the network. So it has found a CPU and the default address is number 2. Then we can load our configuration onto that CPU. Okay, let's asking us a question. You can see there's some warnings there. Do you want to require for this program to be consistent? You also want to download the 2 timers data blocks. Okay, so we add that also. Okay, so this is our PLC. This one is our PLC. The one that I'm moving up and down is our PLC. Don't forget that. So this is So this is our PLC. Okay. Now I want us to actually go and take this to run mode. Okay. Remember, when you download that onto the CPU, the CPU now has all these instructions. They are being executed cyclically now and then. Okay. And the CPU is on run mode, as you can see. Okay. And then there are no errors. Now, I want us to also take this to monitor on. I want us to monitor these two networks. There you go. Okay, so the two networks are being monitored. Okay. Now, I want us to start pressing the start button and see if these two motors will start rotating. We must do it bit by bit. Okay. There's my e-stop, start button, motor A, motor B. And then my start button is I0.1. Let's press I0.1 and see what happens. Okay. So as you can see, both motors are rotating. So after 10 seconds, I want to see this motor. This motor must go off, which is bit number IQ0.1. You see, it's off. Okay. And then I also should see this motor off after 10 seconds. Can you see that? Let's wait and see if it goes off. It's also off. Okay. 100%. Okay. Again, I want us to look at the timers. Let me just take this guy and drop it up there. Let's drag. Okay, let's do this. Let us see the two timers. Okay, while they're timing, not a problem. Then we can also check the 2 bits. Remember, we've got these 2 bits, which is Q0.1 and Q0.2. We can look at the 2 bits. So it's Q0.2 and Q0.1. If there's a tick on 1 and a tick on 2, it means those two motors are running. Okay, so I'm going to start again by pressing I0.1. You can see these two motors, which is Q0.2 and Q0.1, are running. Then Q0.1 will go off. 7, 8, 9, 10. You can see it's off. Only this motor is on, and then also being timed. When it reaches 10 seconds, motor B is also going to go off as per instruction. See, it's off immediately. All right. Now, also, let's look at the e-stop and see if it works. Okay. And see if it works. There you go. With my simulator, let's just start again. We start I0.1. It's running. My e-stop is I0.7. Both motors must stop immediately, as you can see there. Both motors have stopped immediately. Okay. Happiness. All right. Happiness. Now, I want us to start again. Start I0.1. Both motors are running. As you can see, after 10 seconds, these motors are going to stop. As you can see, it's off. After a further 10 seconds, this motor is going to stop. As you can see. Are you guys happy? Okay, happiness. We can start again. Both motors are running. You must tick and untick. You mustn't forget that because it's a push button. You must tick and untick. Okay. This motor has stopped. And then also motor B is going to stop after a further 10 seconds. Okay, so today we have learned how to use a delay off timer and a delay on timer, and we understand the difference between the two timers. In the next lesson, we'll be dealing with counting, with the counters, count down and count up, counter. Okay, we'll also try to include comparators. Okay, happiness. God bless you and be safe. Stay at home, wash your hands, don't touch your face and your eyes and your ears. Be safe. God bless.